Hey everyone, welcome back to the channel. Hope you all are doing well. This is Abhishek on the other side. If you haven't subscribed to my channel, do subscribe to my channel and press the bell icon in order to get the latest notification first. So without much further ado, let's start our today's video. So today we are going to implement linked list. So before implementing linked list, we need to create node. So we'll be needing a class node which contains two public variables. One is the data and another one is the next, which signifies the address of the next node. Now next we need to declare a constructor. In this constructor we will be passing data as parameter. Now we need to store this data to the data present in our class. So for that we will be needing this of data. After storing our data, we need to make our next, that is we need to write as this of next as null, and by this our node is created. Let's see if there is any error. So there is an error, we have missed one semicolon. So let's run it again, and hence there is no error over here. Now let's create a linked list. Here in this example we will be creating linked list containing 3 members, which are 1, 2 and 3, where 1 will be pointing to 2, 2 will be pointing to 3, while 3 will be pointing to null address. So in order to create this linked list, we need to go to this solve function. In this solve function we will be creating our linked list. So let's write creation of linked list. So at first we will be declaring our head. Now our head which will be pointing to the first node of our linked list. So we will be writing head is equals to new of node 1. By doing this we will be storing 1, we will be making node 1 as our head. Now we need to make 1 point to 2. For that we will be storing head of next is equals to new of node 2. Now our 1 will be now pointing to 2. Next we need to make our 2 point to 3. Now for that we will be writing head of next equals to new of node of 3. Now our 2 will be now pointing to 3, while 3 will be null because here we have stored our next as null. Now let's print this linked list. So in order to print this linked list, we will be calling this print function, and where we will be passing head as the parameter. So after passing head as the parameter, we need to have a temporary variable. So let's write ptr is equals to head. Now ptr will be storing ptr is equals to head. Now ptr will be storing the head or the first node of our linked list. Now we need to traverse through our linked list. So let's write this function name as traversal. Sounds great, right? Now we need to traverse. So at first our ptr is currently at head. So we need to go up to ptr not equals to null, and we need to print ptr of data, because ptr of data is actually storing our value of our element, right? Now after printing it, we need to mark this as arrow so that you understand which guy is pointing to which one, right? Now we need to make ptr is equals to ptr of next so that our ptr moves forward by 1. Now we need to make it as null so that the node tree points to null and we can see it. Now let's call this function. So we'll be writing traversal of head. Now let's save it and run our function. So upon running our function, we can see that 1 is now pointing to 2, 2 is pointing to 3, while 3 is pointing to null. So at first we are going to see the insertion in linked list. Now we're going to start from insertion at the beginning. So let's create a function named as insert at begin, where we are going to pass head as the parameter. So let's pass head as parameter. After passing head as parameter, we want to store node 4 to the starting of our linked list or to the head of our linked list. Now in order to do that, we need to make that node or node 4 node containing element 4 point to 1. So let's first create a node ptr which has the address. Let's create a node ptr, right, which contains element 4. Now we need to make this ptr of next point to head. After that we need to change our head because currently our new head is ptr. So let's write head is equals to ptr. After writing head, we need to run the traversal function to check if we get our desired. So upon running our function, so at first we need to call our function. So let's call the function. After that, let's run it. So upon running our function, we can see that head is now 4 is pointed to 1, right, or the starting of our linked list, right. Now let's say that we want to insert an element at the end of our linked list. So in order to do that, we'll be creating another function containing insert at end. Again, we are going to pass head as the parameter. Upon passing that, now let's say that we want to insert 5 to the end of the linked list. For that, we are going to create a node which contains node 5 or element 5. Now before doing this, currently let's check what is our current linked list. So our current linked list is 1 to 3, where 3 is pointing to null, right? So in order to make this tree point to null, we need to know we at first need to know the address of tree. So for that we need to traverse through the linked list. So let's first traverse through the linked list. So that we'll be needing a temporary pointer which will be currently pointing to head. So let's point q to head. Now we're gonna make while q of next not equals to null, right, and then we are going to increment q by 1, that by writing q equals to q of next. After q reaches to the last node, we're going to make q of next point to ptr, and hence our objective is fulfilled. Now let's print our head. Before that, let's call the function. Now let's print our head. Now we can see that 3 is now pointed to 5 while 5 is pointed to null, right. Next we're going to perform insert at any position. So let's first see our linked list. So now we can see we have three elements 1, 2 and 3, while 3 is currently pointing to null. Now let's create a function insert at any position. Where we have passed height as the parameter. Now let's say that we want to insert 5 in the place of 2. Now when you insert 5 in the place of 2, now this one which is currently pointing to 2 should be pointing to node 5, while node 5 should be pointing to 2, right, and hence our objective will be successful. So for that again we need to traverse through the linked list, and we need to pass another parameter over here, that is posh, which will denote the position where we want to insert our element. Now let's create a node ptr which contains element 5 that we want to store at the position of 2. Now let's create a temporary pointer q which will be currently pointing to head. Now let's start traversing through the linked list. So our terminating condition will be q not equals to null. So let's write that condition first. After writing that, we need to see where we have to stop, right? For that we already have a pointer q which is currently pointing to head, right? But now we need to write a condition where we need to check whether our posh is equals to 2. The reason I am writing this because we can see that we need to insert the element at position 2, right? Currently we are in position head, right? And hence this is the position I want. Now posh is also 2, right? Which means that we need to insert this node, that is node 5, or we need to make this guy point to this guy at this position, and hence we are making this posh equals to 2. So after doing that, after making posh equals to 2, we're gonna make q of next points to ptr. But before that, we need to make ptr of next points to q of next. That is, we are making this guy, this node 5 points to 2 at first, and next line we are making 1 points to 5, and hence our objective is fulfilled. Now if this condition is not satisfied, we are going to increment ptr by 1 and we are going to move to our next node by writing q is equals to q of next. Now next we are going to print our linked list. So let's write traversal of head. Now let's call this function insert at any position. Upon calling this function, let's run this function first. So there is an error over here. So error is over here. Insert an O. I should be passing two parameters. That is 2. That is the position also. Now let's run this code. Again, I have written a semicolon over here. So let's cut it and write it over here. Now let's run this code again. So upon running this code, we now see that 1 is now currently pointing to 5 while 5 is pointing to 2. Now let's see how we can perform deletion in linked list. Before performing deletion, let's see our original linked list. So in our original English, it contains three members 1, 2 and 3, where 3 is currently pointing to null. Now let's see how we can delete node 1 or the head of the linked list. So let's create a function delete at first or delete at start. We are gonna pass head as the parameter. Upon passing head as the parameter, now after deletion, we are gonna make this head which is currently pointing to 1 point to 2, and hence we will be successfully deleting node 1 from the linked list because we would never reach to node 1. So for that we just need to write head of next points to when to write head is equals to head of next, and hence our head is now will be pointing to head of next, that is 2. Now let's run this code. Delete at start. So upon running this code, I think I have written, now run this code again. Now upon running this code, we found that node 1 cannot be seen in our linked list. Now let's say we want to delete node 3 from our linked list, or we want to delete the last node of our linked list. So in order to delete the last node, let's first bring this linked list or initial linked list which contains elements 1, 2 and 3. Now for that we will be again declaring a function delete at end. Now in this function we will be having one node. We need to pass head as a parameter. Now if you really want to delete 3, now we need to make this 2 point to null. To make node 2 point to null, we need to know the address of node 2, and we also need to know whether node 2 is the second last node of our linked list. So let's see how we can do this. So let's have a temporary pointer q which will be pointing to head. Now we need to see whether q of next is not equals to null, and we need to keep on incrementing our q of next. Now when this loop gets terminated, we need to store, or we need to make q of next as null, and hence our objective will be fulfilled. Now let's print our linked list. Let's delete at end, and let's pass head as the parameter. Now let's run this code. So upon running this code, we found that node 3 is vanished. Now we're gonna see node at any position. Before seeing that, let me again run this code and see our initial linked list. So our initial linked list is 1, 2 and 3. Now let's write the function delete at any end, delete at any position. Now let's pass the parameter head. Passing this, and also we need to pass the position or the node we want to delete. Here in this case we want to delete node 2. Now again we will be requiring a temporary variable over here, or q, which will be currently pointing to head. Now we need to check whether our q not equals to null. Next we want to see whether our position is equals to 2. if our position is equals to 2, then we're going to make q of next points to q of next or next, and hence our objective is fulfilled. Now using this we're going to making 1 pointed to 3. Now we need to make q is equals to q of next. Now let's print the linked list. So after making this 1 point to 3, we need to break out of the while loop. Now let's break out of the while loop. Now let's run the code. So upon running the code, we found that 1 is now pointed to 3, which is pointing to null. Now that's how we delete the node of any node. Now let's see how we can find the length of a linked list. So let's see how many members are there in our linked list. Now let's run this code again. So now we can see there is only 3 members. Now let's see how we can find the number of members in our linked list. So here in this example, I'm gonna show you the recursive way of doing that. So let's write length of ln, and let's pass the head as parameter. After passing the head as parameter, we need to return 1 plus length of ln, and we need to make head of next. Now what this function will do is that at first our head is currently pointing to 1, and hence it will be incrementing 1, and then it will be pointing to head of next, that is node 2. Again it will be incrementing it by 1 again, and then again it will be moving to node 3. And next, upon moving to node 3, we have found a null. So when we see a null, we need to make, if our head is equals to this node, we need to return 0. And then all these ones which we have got by visiting each of the node will be summed up, and we will be getting the value 3, that is the length of the linked list. So let's see. So let's give a new line at first, and then let's print the length of the linked list. So now let's run this code. So there's an error over here, that is, this should be integer, it should be of int return type. Right. Now let's run this code again. So upon running this code, we found that we have got the length of linked list, that is 3. Now let's see how we can search an element in linked list. Now the searching an element in linked list, the simplest way is to use linear search, because even if the elements in linked list are sorted, if we try to use binary search, it will be too complicated. So let's see how we can search an element 2 using linear search. So here we'll be returning a boolean variable, that is true if 2 is present in our linked list, and if it is not present, we will be returning a false value. Now let's call this function as search. Now where we are passing head as a parameter. After passing head as a parameter, we need to traverse through this whole linked list. Now we can write this in a recursive way, where our base condition will be head of val if head of val equals to the target, let's pass the target, that is the element we want to search, right? If we found our target, we need to return true, else we're gonna check if search of head of next from a target is returning true, then we return true, else we will return false. We'll, so we need to also check whether if our head is equals to null, then we need to return false because it is one of our base condition. Now let's search element 4 in our linked list. So let's write search of 4. Now if element 4 is present, we're gonna write found. We're gonna also have to pass head as the parameter, and if it is not present, we're gonna found absent. We're gonna print absent. Now let's run this code. So upon running this code, we found that it is returning me as absent because element 4 is not present in our linked list. Now let's change it to 3 to see whether it is returning me found or not. Now you can see that it is returning me found, and here because element 3 is present in our linked list. I hope that you like this video. If you like this video, do give a thumbs up to the video, share it with your friends, and subscribe to the channel if you haven't already, and press the bell icon in order to get the latest notification first. So that's all for today. I will see you in my next video.